Hey everybody, and welcome back to Front-End Expert. In this video, we will be discussing CSS methodologies and best practices. The ultimate goal here will be to try to answer the high-level question of what is good CSS? Or in other words, how do we write CSS that scales to large projects while still being easy to maintain? We will look at a variety of different popular methodologies in this video, but first, let's take a look at some of the general principles most of these methodologies focus on. First, and most importantly, we want to be consistent. It should be easy to find code in your codebase, and you should be able to easily assume what classes might exist for a given component. Next, we usually want to minimize how much our CSS is intruding on the HTML. The optimal outcome here would be that we had an HTML file that looked like raw markup with no styling information whatsoever. But as you will see, many of the methodologies will make sacrifices here in favor of other benefits. Within our styles, we also want to focus on responsive designs and minimizing usage of any absolute values. This will ensure that our websites are properly scaling regardless of the devices that a user is using to view the website. Moreover, we will want to respect the cascade of CSS and avoid using any important rules. This will help prevent us from writing CSS hacks that oftentimes just have better solutions. You will see some methodologies solve this by minimizing the differences in specificity between selectors, but we can also just ensure that we are using the cascading and specificity rules as they were intended by the CSS spec. Finally, we usually want to minimize redundant code. This is oftentimes referred to as don't repeat your code or the dry principles. To do this, we can use variables for repeated styles and group similar components with common classes. Okay, so these are all great principles to follow, but now let's take a look at some specific implementations of these principles through methodologies. First, we will look at the block element modifier methodology, or BEM as it is usually referred. This is a methodology that breaks CSS down into three categories: blocks, elements, and modifiers. Blocks are standalone entities with independent meaning. For example, if we had a menu, we could call that a block. We then select blocks by using class names based on the name of the block, such as the class menu. Next, elements are part of a block with no standalone meaning. For example, in the menu, a single item could be an element. We select these with class names that are the name of the block, then two underscores, and then finally the name of the element. For example, we could say menu, and then have two underscores, and then item for the name of that menu item class. Finally, modifiers are for small flags on elements to change little pieces of style or provide variants such as disabled or selected states. These can modify either elements or blocks, and they are denoted by adding two dashes to the class name followed by the modifier name. For example, here we have the same menu block, but we also gave it the menu disabled modifier. You'll notice that we do include both the name of the block and the name of the modifier as two separate classes, separated by spaces as per standard HTML syntax. Similarly, we can add the selected modifier to a menu item with menu item, and then two dashes, and then the word selected for the name of that modifier. Again, we include this along with the menu item class. This can be one of the biggest downsides to BEM because it does cause our HTML to get pretty long with such verbose class names. However, it makes our CSS extremely easy to write and maintain, so that is sometimes a trade-off worth taking. You'll also notice that we only use classes here, which is pretty typical of BEM and a few other of these methodologies. The primary reason for this is to avoid issues with specificity. By making every selector in CSS a single class, every selector has the same specificity. That said, this does restrict our code a bit, so once again, there are trade-offs to consider. Up next, we have Object-Oriented CSS, or OOCSS. This is based on the concept of object-oriented programming, and it is trying to apply that to CSS. To do so, we treat UI components as objects. Then we divide styles into two categories: structure and skin. Structure properties are the invisible properties such as width, height, and margin, while skin properties are visible, such as colors, fonts, borders, and shadows. Finally, in object-oriented CSS, we make a clear distinction between content and containers. This means that we are avoiding combinators or really any styles dependent on DOM location. This methodology has very similar drawbacks to BIM in that you usually end up with very small classes, which can potentially make the HTML code less readable. And next, we have atomic CSS, which is a fairly simple concept. The idea here is to avoid any repeated declarations and make CSS classes for them. Then these classes will get names based on their function. For example, we might have a paragraph with the classes text medium, text blue, and margin 12 to make that paragraph have medium-sized text, blue font, and 12 pixels of margin. This is great in terms of creating dry CSS, but it tends to be the worst methodology in terms of separating CSS from HTML, so this is a trade-off once again to be considering. Now let's take a look at the scalable and modular architecture for CSS, pronounced SMACS. The idea here is to actually split our CSS into roughly 5 different files, although for simpler projects you might not need all 5. First, we have the base file, and this is for defaults, so it is just a bunch of type selectors. Next, we have the layout file, which contains the major structural layout for the page. This uses a combination of ID selectors and class selectors. The classes are usually prefixed with the letter L and then a dash before the name. So for example, we could have L-nav. Alternatively, some people prefer to use the word layout before the dash, so we could have layout-nav as well, and there are just 2 ways to do the same thing depending on how verbose you want to be with your naming. Next, we have the module file, which contains smaller reusable components. These are generally all class selectors, with the name of the component it is selecting, and no prefixes. Then next, we have the state file, which contains selectors for specific states, such as disabled elements. Usually this will just be more classes, and they will be prefixed with the word is and a dash. So for example, we could have is selected or is disabled as classes. Finally, the theme is for style rules for modules or layouts, and oftentimes these are based on user preferences, such as being in a dark mode. That said, many websites won't actually need the theme file at all. Now, the last methodology we will look at in this video will be the inverted triangle, or ITCSS. This methodology is mostly about the ordering of our CSS code rather than having opinions on things such as naming conventions. At the core of this idea is that we should start with selectors that are the most generic, and these will have the least specificity, and they will be the ones that will reach the most elements on the page. This is usually drawn out as this upside-down triangle, hence the name inverted triangle. At the top are settings, which are usually things like global variables that will affect the entire web page. These have the most reach, and they're both the least specific and the least explicit. Next, we have tools, which is mostly for mixins and functions if you're using a preprocessor that supports those. Up next, we have the generic layer, which is used for very high-level generic styles. Oftentimes, this is used to reset the browser defaults, which is a common practice to ensure consistency between browsers. The next layer is elements, which will hold our type selectors, and below the elements will be the objects layer. This will have the most generic classes in our website and is often used for larger containers. And then next we have the components, which holds the style for individual UI components, which is oftentimes where the majority of our CSS will end up going. And finally, the trumps layer will hold all of the important rules, which should mostly be reserved for overriding styles provided by frameworks being used, but if we need any important rules, we usually put them at the bottom, as they are the most specific rules we could include. And it's worth noting that these are not the only possible layers for the inverted triangle. The principle of organization would still apply, even if you're using slightly different layers for your project's individual use case. And that's going to be the last methodology we look at in this video. In general, following a CSS methodology can be a great way to ensure that you have consistent, scalable CSS code, but at the same time, you shouldn't feel restricted to using them. Many projects will end up combining ideas and principles from different methodologies that make sense for their individual use cases, and this is perfectly okay. Now finally, let's take a look at some performance concerns within CSS and how we can minimize page load times using CSS. So first, looking at our actual selectors, browsers actually read them from right to left. So for example, here we have a specific ID, and we are selecting paragraphs directly inside of it. You might think this is efficient because the browser just needs to look inside of that ID. But actually, the browser will find every paragraph on the page first, and then see if they are inside of the specific ID. In general, IDs tend to be the fastest selector, but if we used IDs for everything, we would have horrible code that is hard to maintain. And that said, browsers are very efficient, so the differences in performance between selectors usually isn't that big of a deal on the modern web, but it's still good to know about and to be thinking about if you have a very complex website. Next, we should try to avoid expensive properties where we can. For example, box shadows are actually very expensive, and if you have too many of them on the page, it can slow down the page. Additionally, certain properties are very slow to animate. So in animations, we usually want to stick to using the transform properties where we can, as those ones have been optimized for the animations. That said, once again, browsers have gotten extremely fast, and usually we just want to prioritize clean code and the outputs that we want over micro-optimizing for efficiency, but this needs to be within reason, of course. We should also try to avoid having any unused style, as this wastes the browser's time and it increases our file size. This sounds like a simple idea, but it can actually happen in a few ways. First, it's very easy to delete some HTML code and then forget to delete the related CSS. So you just need to be careful about doing this. Additionally, this can happen when a website becomes extremely large and has all of their CSS in one file. For example, you could imagine Amazon.com probably has a crazy amount of CSS, and if they gave it to the browser all at once, it would take forever to load. Instead, you should just be giving the browser CSS files necessary for the page it is currently on, or in some cases, components that the user is likely to navigate to soon. Next, to help with these large files, we can use a minimizer. And minimizers are just programs that will take our CSS and turn it into equivalent code, but without white space and other wasted characters. As a result, this can make our file sizes much smaller, especially for large projects. Particularly if you are using a framework like Bootstrap, you will want to make sure that you are including the minimized version of that framework and not the larger file. And finally, we can also defer non-essential CSS to prevent render blocking. When the browser gets to our link tags, it is going to complete parsing of that CSS file before it is able to render the page. However, if we have styles that aren't necessary on the initial page load, such as styles for a modal, then we can place those in a different style sheet and defer loading it. There are a few ways to do this, but they are all admittedly a bit hacky. One of the most common solutions will be to change the relationship attribute from style sheet to preload, which tells the browser to asynchronously load in this file as soon as possible. But then we also include the as attribute to tell it that this is a style sheet. Finally, we add the onload property with some simple JavaScript. First, this removes the onload code that we are adding just to make sure the browser doesn't try to run it twice. Then it sets the relationship attribute back to style sheet, which will apply these styles once the browser was done loading in the file, which happened without blocking renders. And finally, we can include a noScript tag, which is a conditional for if the user doesn't have JavaScript in their browser. In the modern day, this doesn't happen too much, but it's still a good practice to be doing. And in this case, we can't run the JavaScript to asynchronously load in our style sheet, so instead, we'll just need to load in the style sheet as normal and have a slightly slower page load. And with that, that's going to be the end of this video on CSS methodologies and best practices. There are, of course, other methodologies that we didn't cover, but they all tend to apply similar principles. Moreover, these performance tricks should be some of the more important ones, but again, in the modern web, these micro-optimizations oftentimes aren't worth the other trade-offs, such as code maintainability, so that is something to always be considering. And with that, I hope you enjoyed this video and learned something new. I'll see you in the next one.